Hey, everybody, welcome back to the History of Automation podcast. My name is Shawn Tierney, and this week I'm joined by my two co hosts, Jeremy Pollard and Gary Wilkinson. And really appreciate you guys coming back for a second episode. After the first episode, I didn't know if you guys would want to do this again or not. So I really appreciate both of you. And let's go around the room, let you guys say hi. Jeremy, say hi to the audience.
Hello, audience. How are you? And I hope I look a heck of a lot better than I did in the first one.
The
My
first one's
my
always rough.
my camera was just at a really bad angle,
Yeah.
and it just made me look flatter than obviously I'm not flat.
Well, and
So
it made you look stretched too. But you know
it
what?
did. It was really, really weird.
A lot of people listen, don't watch because we're no Tom Cruise, we're no famous actors, so a lot of them just listen,
Well,
which
that's
I'm
good.
used to. I'm used to. But in any case, Gary, you want to say hi?
Hello, this is Gary Wilkinson, and Jeremy. It's what's up here that counts.
I don't disagree with you, my friend. Absolutely.
And there's a lot up there. I know.
And we're gonna find out a lot more about what's up there in a moment because this week, Jeremy's volunteered to kind of be our presenter, or how should I say this? The person who's doing most of the talking. We're actually going to be talking to him about um, the history of Allen-Bradley PLCs. We're not going back to the PMC and all those, but really starting at what some would call the PLC one. And in any case, you can see my camera's flaking out here. I don't know why it does that, but in any case, before we get into that, I just want to thank everybody who's watching or listening and commenting. All the social media sites are now focusing on comments and likes. And if I know most of us don't do that because we're busy and we're like conservative and we don't want everybody following everything we click on. But in any case, if you guys do enjoy this show, please, just to keep us online and relevant, please give us a like, give us a sub, leave your comments. I read every comment on every show I release, whether it be on my website, on YouTube, at the Automation Museum. So please feel free to comment. And just want to thank you all in advance. And with that, also, just want to remind you that we're sharing part of our weekend with you to talk about the history of automation in order to try to raise enough money to actually open the Automation Museum, right? A physical and virtual museum, automationmuseum.org. We have a Give Send Go there, which I set up to try to raise money to get the 501(c)(3) set up. And once that's set up, we can start soliciting donations from big and small alike. And I know I have a lot of equipment I've actually had a lot of you send me equipment out there, and I have a lot of equipment, and I know a lot of other people have equipment they'd like to see preserved along with the stories. And one day I hope the stories we talk about on this show will be playing alongside a physical demo in a real museum. But with that, that's enough about the Automation Museum. Before we get started, did anybody else have any points of business they wanted to talk about?
Not me. I'm just looking forward to this sort of desktop fireside chat about. I've been in the business since 1977, which is 48 years, 48 great years. And I'm just looking forward to sharing and having conversation with you two guys.
Okay, Gary, anything before we get started?
I'm looking forward to it.
Okay. Well, yeah, then there really wasn't anything for you guys to answer to, but I just wanted to check with you before we get going. So, Jeremy, behind the scenes, we had been talking all week during work, sending messages back and forth. And so Jeremy put together a really nice list of what he wanted to talk about. So, Gary and I have already seen this. So I'm just going to turn the floor over to Jeremy. And Jeremy, if you could, start off with what you're going to talk about today. And, start us at the beginning there of the content you're going to cover.
Well, the history of the PLC has been, battered to death, if you will. And the Allen-Bradley timeline has been sort of battered to death. As opposed, with regards to this came out this time, this came out this time, this came out that time. But one of the things that always sort of surprises me is so many people complain about the tools that they have today but for crying out loud, they have no idea where the heck we have come from, so that hopefully their appreciation for what they do have perhaps becomes a little bit better understood. So my thought process was to basically show the chronological technology evolution of Allen-Bradley technology, PLCs, I/O, communications, software, etc., and basically suggest that where we are right now is not a lot different than where we were 30 years ago from a fundamental perspective. Now, sort of try to create hooks from point A to point B to point C and so on and so forth, so that, you know, people can understand, well, that's where it came from. And the reasons why sometimes we'll never know, but a lot of the stuff came from, well, if you could do this, can you do that? And, you know, there's a lot of the larger customers, I mean, automotive being the main sort of group, if you will, because of the discrete control that Allen-Bradley started in. And part of the evolution is the move into process. So the Procter & Gamble's and the Johnson & Johnson's using PLCs in process-based applications, well, that requires a whole different set of not rules, but rules than discrete does. So the market widened, and then they had different requests and requirements, and so on and so forth. So the mindset was to try to create this journey and take you from, you know, the beginnings in the early 70s to where we are now, and try to connect a few dots as to the reasons why we are where we are, and the fact that it really isn't a heck of a lot different than where we were 30 years ago, fundamentally, if you will. So my thought process would be, a title for this particular chat would be, if you build it, they will come. And I strongly believe that the reason why the PLC was invented, we all know, is because of requests from GM and Bedford Associates, which became Modicon, was involved, DEC was involved, and there was a fourth company, and Allen-Bradley, and the fourth company, which I can't remember the name of.
3i.
And the 084 was born, and the PLC was, I guess the Allen-Bradley contribution to this was the PDQ-2, which was just so cumbersome to use. And they set out on a mission to become a force in the automation world, the new world that was being born in the late 60s, early 70s. And the journey that I'm hoping I'm taking you all through is from that point to this point.
Yeah, you know, if you read the contemporary stories about that, right, the people at GM who liked the Rockwell backed 3i, PDQ, PDQ2 were the people who were the computer programmers. They really liked it. They really liked it, right? But the electricians who are part of that, you know, probably the major part of that competition, the people behind it, who, you know, the guy who drafted the spec, the RFQ, or request for sampling, I don't know what they call it. But in any case, they really like the 084 because to them, you were doing lateral logic, right? Whereas with the Rockwell, and I show this in my article, you were converting, you know, lateral logic into XIC, OTE, you know, text. And you can put a contact image on top of an XIC, but if you're still typing it in as XIC, OTE, that doesn't feel like lateral logic. So let me pitch it back to you. But yeah, that was the clue to the Rockwell people who ended up buying 3i. That was the clue, that was their cue that it needed the program in lateral logic, because that's what the people who maintained this are going to know.
Indeed. And one of there was a discussion on LinkedIn about structured text and why everybody should be using structured text. And it's easy to troubleshoot, and, you know, blah, blah, blah. And it's kind of like, you guys are out of your freaking minds.
Yeah, audience, know your audience.
You have to. And the one thing about what everybody seems to be forgetting is that there are developers, and then there are people that maintain it. And the people that maintain it typically are in the neighborhood of 40 to 60 years of age, where they've grown up with ladder logic. And the 3 a.m. phone call, one has to figure out who's going to answer that phone call at 3 o'clock in the morning and to try to get something fixed. So you've got to boil it down to whoever is looking after or maintaining the system. And by putting fancy stuff in from a development perspective, like maybe indirect addressing or something like that, a guy on the floor, is he going to understand what's going on? And secondly, is the company going to invest in the training required to allow that person to sort of manifest a solution to whatever the problem happens to be? And I think one of the reasons why we are hardly different from 30 years ago is strictly because of that. The people that are troubleshooting the systems and maintaining the systems don't have a wide, and this is just an assumption, they don't have as wide of a technological spectrum as people who are fooling around with the computers and writing basic code and writing ST routines and stuff like that. They don't have that spectrum that a developer typically would have.
Well, I want to jump in on that too, to back you up, because people who go into trades to be an electrician or technician, typically a part of their background is they rejected being a coder, like a full-time coder. They didn't want to do that. And people who want to be a full-time coder have very likely rejected working on a plant floor, being a troubleshooter, being somebody who does the wiring and troubleshoots the wiring, right? And so that's where I say know your audience. It's like, these people are already on these other ends of the spectrum because they chose to be there in many cases, right? And so while structured text would be great for some people in some applications, you got to know your audience, who's maintaining this. And if the guy maintaining this is not a PLC, not a programmer, not a C programmer, JavaScript, then you're probably giving the wrong thing. And then I know some people will compromise and they'll take their structured text and make a nice block out of it, where all the electrician has to know is the goes insas and the goes outas.
Exactly.
And that does make sense in some respects, especially if you have proprietary knowledge, intellectual property that you need to put in that code. But that I just wanted to share my thoughts on that, because it to think that everybody's going to go to structured text to me is kind of like, living with rose-colored structured text classes.
Indeed. But, running stuff in alternate languages is fine as long as it's abstracted for people that don't have to know about it. But it also means that everything needs to be tested and bulletproof so that there's no possibility of
that's true. Yeah.
The routine screwing up. So, fault control, fault tolerant, traps and all kinds of things that need to be put in there. So, yes, sir.
Can you describe the differences? I know what direct addressing is. What is indirect addressing?
And
how would you use it?
Okay, indirect or indexed addressing came about in Jeepers Creepers. You know what? I think it was the PLC 3 is where it was introduced. And effectively, because we use direct addressing, like for an integer file word, like N7:0, if you will, or in the memory map of the PLC. And again, this is where something gets a little fuzzy as to the memory map of the PLC3. If you wanted to go to an address of 400, you would put in the address 400. But if you wanted to go, and I think the indirect addressing came into And again, memory. It's just memory because I'm more relying on file-based programming where you have an integer file base. So it's like an integer file, which is typically identified as with a letter of N. And then you have different file numbers. So you can have 7, 8, 9, 10, 11, 12, or what have you. And then there's the word. So you've got the file type, file number, and the word address. And through indexed or indirect addressing, you can take the file number and use a pointer within the program to point to the file number that you want to access in whatever the instruction happens to be. So if the value of the word, so if you had N, and the way that you would program it would be N bracket, let's say N12:1, N bracket, the value that's an N10:1 would be used for the instruction that you are trying to use in the code. So if you had N bracket N10:1 bracket :200, then it would be the integer file would be based upon the value in N10:1, and then it would be word 200 in that particular integer file. So for recipe control, shift register control, data handling, creating an onboard database within the PLC itself is where the indirect addressing would be used.
Now, I assume you're probably a decade before the introduction of the IEC standard, which may be a whole different conversation in your chronology. Is that a reasonable assumption?
Tag-based addressing that we use typically today, again, you can have indirect addressing using tags. So it's, it's like speed set point 1. Or if you have an array, so you create an array, and in that array, you've got 10 motors, and you want to have a single routine to set points for each of those 10 motors. Speed set point 1 bracket, motor 1 end bracket. Would the motor 1 tag, the value in that would indicate where to point to within the array.
I'll just jump in here. I just remember as a kid back in the late 70s, using loops in BASIC, right? So you want to check out a bunch of things. You want to know, was any value over, X? And so you would do maybe a for an X loop, and you would say for X equals 1 to 1,000. And then you would use X as your variable. So data X, right, would be data 1 through data 1,000. And you'll be able to check all your variables to see if any of them were over range. And that really is how a lot of people use index and indirect addressing, slight difference between them, but pretty much doing the same thing. Is it allowed you to go through a whole, like, let's say you wanted to go through N70 through N7-1000, right? PLC5, right? Because the slick can't go that high. N70 through N7-1000, you want to check, make sure all those numbers were under, I don't know, 15,000, right? Well, you could use your indirect or index addressing to put an X there. So it's N7X. And that's what Jeremy's saying is the open bracket, close bracket. Whatever you put in there is your X, right? So it could have been N10:0 that's inside those brackets. And it just allowed you to do a loop in the PLC, right? Which, of course, you wouldn't want to do a jump back because you could hit your watchdog, but it just allowed you to go through a bunch of records. Maybe you wanted to go through a bunch of motors to see if any of the alarm bits were flagged, or recipe. Hey, the user has a panel view and he selects down the list. He goes down to recipe number 5. So you use that as your indirect address. So N7 bracket, whatever he selected on the panel view, boom, and that gets you those values. So extremely powerful, but if done incorrectly, it could be very hard to troubleshoot.
Well, yeah, it can be, and sometimes you have to use it. Because of the application.
Well, early on, you'd run out of memory without it.
A big deal.
You just didn't have enough programming. Matter of fact, the father back week, Jeremy, you're probably really aware of this. the farther back we go, the more we had to use tricks like this because of memory. Memory was
yes.
so limited. We had to use
It
every
was.
dirty trick in the book.
No, it absolutely. And of course, part of the evolution of a PLC family, like the PLC 5, PLC 510, 511, 512, 515, typically the different processors were based upon the number of I/O and the amount of memory. So they came up with a different catalog number for each version, and it was based upon the amount of memory and the amount of I/O for the data table that it would create. And so again, sometimes you had to jump through some hoops. But I think the indexed and indirect addressing came from computer programming. Pointers. I mean, C used pointers all over the place. So the merging, I think, of sort of IT and OT started back in the late 70s. People were programming in Fortran or COBOL or what have you, RPG. But computer instruction sets like on, the DECVAX, IBM 360, 370s, used these methods of data control. And the guys that are writing the firmware in the processors, basically, I'm sure that they would sit around drinking a bunch of Jolt Cola and eating pizza and saying, why don't we do this? It'll be fun.
That was me.
In fact, it worked well, and I've used it extensively in a lot of the code that I've written because I typically want to use a data-driven program, not a sort of a bit level program, if that makes any sense. So anyhow, thanks for your question, Gary. Hopefully I answered it.
Absolutely. Thank you.
Of course. So if you build it, they will come. And we started back in the 70s with the PLC, and it was a 1774 PLC. I've got a spreadsheet over on this monitor. So if I look away, I'm just trying to refresh my memory, if you will. And the 1774 PLC had remote I/O. It had there was a largeness to it. It was a multi-slot chassis. So it had scanner modules, computer interface modules, program panel interface. But you could have multiple memory modules in there as well. And if you look at think about the compact and control logics we have today, it's a multi-slot chassis. But the multi-slot chassis now, you can also have I/O as part of it, right? But the compact logics chassis, there's a processor side and there's an I/O side. So again, a lot of what we have seen as far as the evolution really has sort of come full circle, if you will. So one of the things that came out of the 1774, and it was called a PLC because Allen-Bradley trademarked PLC. So it's a legal trademark of Allen-Bradley at the time. It had a definite purpose program panel with computer keyboard type keys, and they used symbolics or symbols on the keys themselves. So there were, examine on, examine off, OTE, and of course a number pad for entering in the octal addressing, which a lot of people had trouble with. Mm-hmm. So and one of the other things that was of interest is the fact that when you wrote a program, you downloaded it to the PLC and it stayed there. And it was in memory, and it was ferrite core memory, very expensive, if you will. And to back the program up from the PLC, we used a cassette recorder. And we had a back then there was a serial printer called the Texas Instruments Silent 700, which ran at 1200 baud and used thermal paper.
Oh yeah, thermal.
And so you had to take and print, the report generation was done through the program panel, and you had to store the output in a place where it wasn't too hot, because thermal paper would start to degrade. So take that away from a USB 1 terabyte stick where you're storing all of your computer generated code. We're a far cry from that now today, for sure. Part of the process, I think, from the 1774, the remote I/O really made a difference because it took the concept of distributed control. It started back then, because then all of the I/O can be located on the line, if you will. So that it would reduce panel space, reduce wiring costs and installation costs. And that was back in the early 70s, and we're still using that today. We're distributing so many different things, but from a point of view of straight PLC I/O, we had it back then, and we have it today. In the late 70s, the 1771 I/O structure was introduced with the PLC2, and then came the mini PLC 220, mini PLC2s. They were bit-based with 12-bit BCD instruction set for compare and math instructions. And everybody said, well, we need to be able to work on multiple groups of data together. And so file-based instruction sets and processors came out in the late 70s, and it became the mini PLC 205, 215, 216, 217, PLC 230, and they created the ability to have a file-based instruction set, like a file-to-file move, word-to-file move, and this is also the beginning of indirect addressing per se. Because if you did a word-to-file move, you can control the content of a control data type and control the value in that control data type to index into the file wherever you needed to go. So the file instructions always had a control element associated with it. And from the other part of what people were wanting was communications, and the Data Highway 2 came into being, typically to interface with DEC VAXs because they were being used for data access. And there was a lot of times where people would write fault routines in the VAX, which just kind of blows my head apart a little bit, but they wanted centralized fault recording and reporting. So they did it through the VAX, and they did it through DECnet, through their networking. So networking started to become really a large part of any sort of PLC installation back in the late 70s, early 80s. And we needed more power because the PLC2 wasn't fast enough. And so PLC3 was developed. And again, the PLC3 was a multi-card chassis-based processor using 1771 remote I/O, massive amounts of I/O that you can have. You can have memory modules that introduced error detecting and correcting RAM modules for the processor. The redundancy issue was introduced as well. So now you could have two CPU boxes, but you had the ability of being able to have failover should one go bananas on you. So again, that whole idea of redundancy, like the Triconix systems, where, they were triple redundancy. Well, this was just dual redundancy. And it was mainly to identify hardware failures. And then everything, I think it was an M3 module that everything was being shipped over through memory. So it was sort of a bumpless transfer. And that was the hope.
Was the famous application Space Mountain? Do I remember that correctly? People used to always say, well, they got PLC 3 hub backup on Space Mountain down in Disneyland in Orlando. Yeah. Did you hear that? Did you ever hear that?
Yeah. And there's a lot of PLCs in the amusement industry.
Oh, yeah, definitely.
Yeah. And it just goes to show about how everybody thinks of the reliability of them.
And I this is one of the, I'll just pitch the Automation Museum. I never get a chance to get hands-on with the PLC 3 or the PDQ or the PMC or any of these really old products. I mostly slotted at the PLC 2, but wouldn't it be great to have these things running and have people be able to share their knowledge with other engineers? I'm sure there's some out there running. I'm sure those people probably don't want to upgrade them for sure, but in any case, yeah, I mean it would just be great to preserve that knowledge and history, because a lot of what was done there is the reason we have what we have today.
Well, exactly, and again, it since the 70s was a revolution, and since then it's been an evolution of product and technology coming from various parts of the world and various parts of industry that sort of culminate within one form factor, if you will, like the PLC 5, if you will. It's a migration from PLC 2 and PLC 3. And the 3 created online programming. So you had online edits that, so you could, again, that's the first introduction. And the PLC 2s also had online editing through the evolution of software. So with the early 80s, one of the hugest, probably in our lifetime, one of the biggest introduction of technology was in 1981 when the IBM PC came to being. Mm-hmm. And the IBM PC allowed all kinds of people to now become computer programmers, right? And BASIC came into play. So people were fooling around, creating stuff. And in 85, all of the third-party programming packages that were out there, third-party DOS-based SCADA packages and HMI packages. Zycom and Nematron started with panel-mounted PCs. It changed the landscape sort of overnight, if you will. And because of the, hang on just for a sec, because of the ability of the masses to be able to create and generate code, people started to want more and more out of their automation systems. And Allen-Bradley, I don't know exactly how this became, but they third-party or private labeled a documentation system from Zycom. And it was $25,000. And what it did was allow you to add descriptions to each of the addresses in the program. So the whole idea of documenting your program from a Silent 700 on thermal printer or a printout, because Epson became popular and 132 column printers, and you wrote in the descriptors, right? What all the addresses were and so on and so forth. And now you could have it done for you if you could afford it. But that, again, that is an extension of the IBM PC and computer, even though it was CPM based, it came from the computer side of technology, and it made its way into automation.
Now, and I just want to ask you a story if you heard this. I had heard that the original PLC2 programming software one of the original packages was created on the Apple IIe by the founder of ICOM. Have you ever heard that story?
No, I had not. So was that Pete or Scott?
I'm trying to go way back into the early
Hmm.
90s when people would talk about this before ICOM was purchased. And it's interesting to me because the IBM PC was so revolutionary in all businesses.
Mm-hmm.
But and this is what I tell people, is like, pretend you had to program your system, very complicated system, with an ATM machine, because
Mhm.
that's pretty much what you had. You had a
Yes.
few buttons, right? And
Mhm.
you had this big old CRT screen and not a lot of flexibility. You didn't have any cloud saves or anything like that. You
That's
didn't even
what you
have a
had
full
right
keyboard.
there.
Yep.
Okay.
And every time you pressed something, it beeped like an ATM machine. Beep, beep,
Yeah.
beep. There was no there's none of that going on.
None of that going on at all.
Yeah, single key at a time. So when you throw in an IBM, just think of what it did for word processing, right? I was in
Mhm.
college when it just started coming out, and it was like when I was working, I started out in the military industrial complex before I got into this business, thankfully. But it was so easy to change the spec. Well, that pod's not making a spec. Let's go change the spec in Revit. Just go over
Mhm.
to, at that time they had Macintoshes, but go over to your personal computer, you edit it, reprint it out, you're done. And
Mhm.
it just lightened it. So if you can imagine what that does for automation, just being able to save your programs on a disk,
Mhm.
um, edit your programs quickly, add your documentation. It is like night and day. It's like a regular phone versus a smartphone. It's like a dumb TV versus a smart. It
Mhm.
is just makes life so much better. Am I going
Yeah.
over the top with that, or?
No, I didn't hear the Apple II thing. I know that back in the where the heck am I here? There was I think it was 85. I think was when the first IPDS Allen-Bradley software came out for the PLC-5, because the PLC-5 came out in the mid 80s, if you will, and the only way you could program that is with software. So the
Yes.
T1, T2, T3, T4 era was gone, and
T47,
so
T45, T50. You're talking
the T50, yeah,
computers.
well,
These are
yeah,
Intel-based
basically
computers. Yeah.
portable paperweights.
They're huge. They
Oh,
were as well. The T50 was probably, I think it was heavier than a T3.
oh,
It was heavy.
far by far.
And then you couldn't.
It was,
They said don't use the handle as a handle. I love that part. Oh,
uh,
that's a keyboard rest. That's not a handle. But PCs. I mean, it was just night and day what you could do with it.
oh,
And
absolutely.
and this is where you start seeing IT coming back in and getting involved, because now they have to help. They have to provide computers to the industrial automation side and so on.
One of the stories that I did hear about, in 85, the PC came out. In 81, we're 4 years into it. We're at 46 Pentium processors. Moore's Law was acting out in full force. This thing called a laptop was being generated back in the mid to late 80s. And it was a computer. So when industrial based software became somewhat of the norm, with the Teledenken resources, ICOM, Graysoft, Taylor Software out in Edmonton, DMC out of Detroit, I think where they were, and there was a whole whack of other vendors that had developed DOS-based programming software.
Yeah.
But you needed something to run on. And so the laptops were already there. So they were brought into the industrial automation side. But the IT guys had a problem with that because it was called a computer. And anything to do with computer, that's on our side of the fence. So when they placed orders, and I know this happened with a particular automotive plant in some Canadian city somewhere, what they did was the PO was for a programming panel,
Amen.
and it was a Data General laptop that Rockwell private labeled,
Yes.
and they called it a programming panel, not a computer, so that the electrical control engineering groups could buy it because it said programming panel. It didn't say computer.
Well, programming terminal, but yes, I can
Yeah.
confirm that was very important, that our quotes said programming terminal, not computer. We could not have the word computer anywhere on there, or else they wouldn't be able to place the order.
No, and when it landed, people just went squirrely. Like, you shouldn't, you have to go through us for these things. Well, no, you don't.
Well, and that was great because they had the AB logo and it said programmer on it, right? So it's like, this ain't a computer, this is a programmer. And to some extent, they were hardened. They were more expensive than a regular computer, and they were rated for much higher temps. Not office grade. I've had office grade computers, and Gary, I don't know if you want to chime in, but I've had also office grade computers that in a hot day for the Northeast, they just don't work well, right? They start flaking out, right? You get over 100 degrees. So there's a big difference between industrial and standard computers.
There always has been. A friend of mine, Ed Boutillier, started Stealth Computers out of Toronto, and he industrialized commercial hardware, if you will. Yeah. And that may be a little bit of a misnomer, but higher temps. Some people wanted conformal coding, depending upon the environment that it went in. Higher noise rated power supplies. Those sorts of things that make an industrial device an industrial device.
And I just want to bring Gary in for a second, if you don't mind, Jeremy.
No problem.
We were talking about Triconics in the last episode. PC programmed, I'm assuming. By that time, it was the 80s, right? So programmed it on a PC?
Absolutely, a program on a PC, and a Ladder Logic was the only game in town.
Okay.
When I came in, actually, because I was also in the military industrial complex for quite a bit, and we went through the period of, well, we actually did see an Apple II, but it was the WANG terminals that kind of connected the aerospace industry. Yep. Getting into the PLC was just the best timing because IEC 1131 came out, and it was, and so we immediately said you can use several languages, but we strongly recommend function block diagram. But that's, we're not at that story yet. We're probably still chronologically 10 years away from your story, your history right now. And of course, that was a big thing back then. That we're talking early mid 90s, I guess. Jeremy, correct me if I'm wrong about the IEC standard coming out. So but from day one, we could use Triconics again, late 80s. It was Ladder Logic only, and that was fairly easy and really understood.
Mm-hmm. What about function block? I mean, DCS systems were around, right? The Honeywell,
absolutely.
Honeywell 2000.
That sure sounds familiar. very, very familiar, yes.
Yeah, Foxborough, Fisher, Provox, all these guys, and they all use function block.
Right, yeah, but it wasn't, I guess, popularized for actually just be able to write applications for that be understood, and troubleshooting is the big word that it was just, and of course adding color to the troubleshooting. Red, green. Hey, we got it. We got that on our HMI display. Let's go, and that was really an enhancement. But before, I agree with everything you say as far as kind of the before and after IEC.
And they were Unix-based, I think.
Well, I think for process too, function blocks, and I think that's the whole framework story. But I think that's still we're talking mid 90s. So let me turn it back to you on our timeline. We were getting into the PLC 3 era, and I think you did a good job summarizing that. And just picture my head, Space Mountain again. But so after the PLC 3 era, or was there anything else on the PLC 3 you wanted to touch on?
What happened with the PLC 3 is the applications that a PLC wouldn't or couldn't get selected for because they were slow. So for high-speed processing, these sorts of things, and there was an application at one of our liquor control board distribution centers. They put Allen-Bradley PLC3
Mhm.
up against a DEC VAX,
Oh yeah.
and the PLC3 was too slow for what they needed to have done.
Mhm.
So as the PLC3 and the 310 sort of grew, larger installations and installations that required speed sort of came in under the umbrella. And so because of the PLC3 and the speed of it, the applications that it was applied to started to grow, and they demanded more process stuff. So we already had stepper and servo control in the 1771 IO structure. So integrated motion was back in the PLC2 era, but it wasn't like integrated motion today, but it was still there. It was in the IO chassis. And the PLC3 could also be used for motion, but now analog process had the processing power and the memory for larger applications. And because there was larger applications, it became data centric. So Advisor graphics was born because people wanted to have access to data. They wanted to be able to see things, again, Nematron and Zycom for HMI. But you had, the GA module with an M10 hard drive, 10 megabyte, a 10 megabyte hard drive. Wow. And it was big, like it had its own enclosure, but people wanted to have access to the data in these larger applications. So centralized data storage was sort of, it evolved from having it local within the memory of the PLC, and data was written out through the GA modules and RM modules to the M10 through a specific instruction set that you could get for the GA module. So that led to this thing called the Pyramid Integrator, which was, DEC based, and it was for data centralization. So we started the whole movement towards a sort of server-based system for data aggregation, and that was back in the late 80s.
And for those who have never seen a pyramid integrator, this is a Rockwell. Rockwell would sell the chassis, power supplies, PLCs, vision modules. This thing was probably not twice as tall as a PLC 5, maybe 1.5 times, but everything was thinner. And its claim to fame, I think a lot of the paper mills that I work with liked it, is you could put a VAX in there, right?
Yep.
Right
Yeah.
in the same chassis. And it also
Yep.
supported multiple controllers or processors in the same chassis.
Right.
And it's one of those things I only get to touch a little bit on. I actually had somebody donate a chassis with the vision module, the CVIM in it. But it's one of those things where I would love to understand it here, years afterwards, after its heyday, understand it. But I think, I think if we look up to this point, Jeremy, and you correct me if I'm wrong, I think we've learned a few things, up into the age of the PLC3 and the Pyramid Integrator. Number one, people want to program in the language they prefer. So if you're on the plant floor and you're in charge of keeping the machine running, you want something that looks like ladder logic. The other thing I think became very important is people didn't want to do home runs to every single IO point. When you look at a paper machine or some of these long, big systems, that's crazy, right? They want to run a twisted pier to all the different points on the machine where the IO is actually located. And so distributed IO became extremely important because there's no way, and some of those signals just won't make it that far in the first place. And then the cost in wiring is outrageous, right? So networking became really, really important. And I think, there became a differentiation between something needed to be backup or redundancy or high-speed data to something that had to be clickety-clack, can handle lots of relays and sensors and whatnot. And so you see that, people wanted to use programmable controllers for everything, but there were definitely process versus discrete control versus motion control. We're starting to see these islands of specialties that, a general purpose product has a hard time being great at all of them. And so this forces vendors into having multiple models, some that are great at this, some that are great at that. But then we also see, ease of use with the programming, right, in the IBM PC, but we also see the desire to get data and to visualize data so early in the life of, even before the IBM PC, but the IBM PC made it. And there was an explosion of companies, and we'll talk about Wonderware next week, but an explosion of companies who jumped on that IBM PC and said, we're going to make software that program your PLC. We're going to make software that visualize your PLC. We're going to make software that collects data from your PLC. And so this is all before we hit the mid 80s, if I'm following the timeline, with the PLC 5, right? And so these things are all defined, and even trying to network VAXs and PLCs together, right? I mean, mainframe computers and lowly PLCs to each other. This is all, the table's already been set by the 1980s, right? A mere 15 years into the existence of this product we call a programmable controller.
Right. And the one interesting part about graphics and the PLC-5 and communications is, the PLC-3, the PLC-2s, they all had communication capabilities, graphic capabilities externally through Advisor or Westhead systems or something along those lines until Intellution came out in 85-ish. But the PLC-5 was just an extension of the mini PLC-2 with basically a PLC-3 level of functionality. So again, it was smaller footprint, smaller form factor, built-in communications. I can't remember exactly when the web server started to come in, but you could use SFC, sequential function chart, in a PLC-5. You could also use structured text in a PLC-5 when you had the updated firmware. So, I mean, that was back in 85 to the 90s. And here we are 35 years later, and we're still talking about it. We're still using it, but it was there back then. I mean, but most people wouldn't give it the time of day.
There is a huge list of advantages going from the 2 to the 5. It's just massive. We can't even cover it all. But I'll tell you what, once people went PLC-5, they didn't go back to 2.
No.
It was, and I'm not even talking about DOS software versus Windows. No. It was just phenomenal. Just being able to create integer files on the fly as you wanted, and 10, 11, and 12, and 13, F8, F9, F10. That just blew things away. And but go ahead, Gary.
Yeah, I had a question. I guess you mentioned Intellution, and was there a direct relationship there, or did it enhance the capabilities of the PLC-5? Obviously, Intellution was kind of considered the precursor to Wonderware. So what was that relationship of Intellution to the PLC-5?
I'm not sure that there was a direct.
Okay, this is my question. Yeah,
but I think. One of the things that Allen-Bradley did, and they saw and identified that they can't do this all by themselves. So they opened up their technology through technology transfer agreements. So the Data Highway Plus that was introduced in PLC-5, token-based communication protocol, and in order to sit on the Data Highway Plus, they develop interfaces, of course, but in order for you to actually write software to sit on that bus, you needed files from Allen-Bradley in order for you to do that. And Intellution was a technology partner because they needed the communication protocol to sit on the network to provide SCADA control and monitoring over that particular network. And the PLC-2 data highway just didn't hold a candle to the Data Highway Plus because of speed and token passing. It was just easy. I mean, the PLC-5 was just easy.
Easy. And it came with almost they did release smaller models, but every model up until they released the smaller ones came with a Data Highway Plus and a remote IO.
And a scanner module. Yeah.
Built in by default, PLC 515 and up, and that was just like, you have it. You have your remote IO, you have your Data Highway Plus, It's all built in to the process. They eventually released a 5, 10, and 11 where you just got one port, but up
Right.
until that point, every PLC 5 had data hub plus remote I/O, and that was just built in, and that wasn't some extra card, and it was just all set on the side of the unit with the dip switches, and it was like pretty awesome. But I would, I want to take this opportunity, if you excuse me for a second, Jeremy, is I want to tie on a point that Gary said. So if you're listening and you know all about Involution, we want to get you on the show. The three of us would love to ask you questions because we have our own history and expertise. I recently had somebody reach out to me. They saw when I was showing off a Cymax that somebody had donated. They're like, "Oh, I was on the original development team." I'm like, "Please come on the show. The three of us would really like to interview you."
Yeah.
Because I don't know anything about Cymax PLCs except someone donated one. So I want anybody listening out there, if you're passionate about industrial automation and you want to share your stories like Gary and Jeremy are, we invite you to come on the show. Reach out to me, Shawn Tierney. You'll see all the links in the audio or video version of this podcast. You'll know how to get in touch with me. Jeremy, sorry, I thought that was sorry to interrupt, but I thought that was a great segue into asking people to get it. And we want to hear your comments if you think we're wrong about something. We're not infallible.
Well,
we make mistakes.
The one thing that is important to note is that based upon age-related issues, memory may not be as clear as it once was.
Definitely. That's why they say eyewitnesses are the worst is the worst evidence, because people don't
true enough
always remember things accurately.
You talk about the PLC 5. I think PLCs back in the 70s were specialized solutions to specialized problems. I would submit that the PLC 5 and the 484 at Modicon 484 at the time, I think they became the general purpose, horses of factory automation that you can apply to just about anything. And the heel of the hockey stick happened in the mid 80s when the PLC 5, 484 were there, and everything got every application had a PLC, how can we use it sort of mentality, as opposed to, this is the way that we're going to do it. Well, we can't or shouldn't use a PLC. I think the PLC 5 and the 484 catapulted the whole mindset of automation. From every project would get, PLC would be considered for every project from that point sort of going forward. And with the Wonderwares and Intellusions of the world that came out, and you can do what with this? And in order for you to have that, then you need this. And so they all, HMI and PC-based or otherwise, everything just really, really took off in the 90s. And
I was just going to say, I think, that's a good point about inflection points. So that first inflection point I saw was, if you look at 1969, where the 084 and the PDQ2 and the DEC, they're all competing at GM for that coveted standard machine controller. And then you look after that, 70 and forward, you just see an explosion. Everybody and their brothers making programmable controllers. Really, you had nobody marketing them. Now you had all the major industrial automation companies marketing them, right? And that inflection point 1. Inflection point 2, I do think, was the IBM PC, right? So now you have this IBM PC that just makes it easy to program. And I think that power, we see the power to be able to make a PC cheap enough, also is represented in the what you said, the 484 and the PLC 5. So we get a generation leap because we got a PC we can program with, but also we're seeing the hardware also making a generational leap as far as usability and power, right, and speed at the same time. And it's just, that's the second. I think the third inflection point would probably be, and I think this is especially true for packages like Involution and Wonderware, is Windows 95 and 95, because that just made the operating system so friendly. Anybody could create a SCADA program in InTouch or in iFix or whatever. So I'd throw that out there. You guys may disagree with me, but that's kind of my thought process on those inflection points.
The late 80s created a personal computer guru network, because you had to use quarter deck extended memory managers, and you had expanded memory, and to get 2 megs
And
worth of
expanded
RAM.
memory.
Pardon me?
Extended and expanded memory.
Yes, extended, and so the personal computer hardware was lagging. And then when the Pentium came out and protected memory areas came out, and the cost of memory, onboard memory, and the memory model within the OS changed with like Windows 2.5 was questionable. Windows 3.0 sort of changed a lot of things, but it really didn't grow until Windows 95 came through and the hardware was there to support it. And as you say, I think everything at that point just went ballistic, and people were okay in using a Windows 95 platform for their HMI and for some of their SCADA stuff. Communication possibilities were already there. Say Data Highway Plus was there. Ethernet was starting to come in. So many Windows-based graphics products sort of came out. The Slick 5, the SLC family was introduced, and it brought in a DF1 protocol, which was an old protocol. It came out with serial communications, but then went to Ethernet. Ethernet starts coming in. Now you've got networks everywhere. And then boom, the mid-90s come in, and this thing called the Control Logics hits the freaking market. And the Control Logics is the culmination of the PLC-3 and the PLC-5 and the Pyramid Integrator, all in one nice, slick package, new I/O systems, built-in everything, integrated everything. And I don't know exactly when Motion came in, but the robotics surge that happened in the late 90s, early 2000 required integrated motion control and interface into robotics, which means you've got to have communications and proper motion control instruction sets and so on and so forth. So the Control Logics really is a 1774, sort of like a PLC-3, but with a PLC-5 inside. But now it's just a whole new form factor where you have to be able to expand on it because the PLC-5 kept running into roadblocks.
Yeah,
So
and I got to give Rockwell kudos too, because version 1 of the Control Logics, right? So I don't know, 1989, right? Version 1 of the software. You didn't even have string tags. It was like, it was so much missing. It was ladder logic only, but they supported that original L1 controller through 13 revs of software. You can actually use I have L1 controllers in the school that we can use version 13 on. You can pretty much do anything. Well, pretty much, almost do anything that you would do in a modern, L8 or soon to be L9 controller. So it's just amazing technology. They did build, they built the hardware to last, and they were able to add so much functionality through software. And I was just very impressed with it, and just a great platform. I especially always loved that the communication cards could operate separately without the controller having anything to do with them. So you can bridge through your different networks. Just another leap, inflection point, at least for the Rockwell world. Another inflection point.
I believe the mid-90s again was a true innovation with the Control Logics and the implementation of IEC 61131 tag-based programming, and the instances of POUs, tasks versus routines, and something lost. Sorry.
No, I'll throw out there too. Not just PLCs, but HMI. So this is where we see Rockwell start getting the competitive on the HMI side and release their little PanelView 550s, which sold like hotcakes. Right? There were some design flaws on them. That long-term, light bulb that was used in the back and the fiber bundle was a kind of a downside. They would fix that in later years, but that and then the gas plasma monochrome PanaView 900, which was not in production very long, maybe a couple of years, but had such a beautiful bright screen. Those sold like hotcakes. They were finally an HMI for, not a 12-inch CRT.
No.
OEMs are looking at 12-inch CNT and say, I can't fit that on my machine. But you gave them this small PanaView 550, and they're like, yeah, I can use that. And the software, again, originally came out DOS-based, but quickly migrated to Windows, and was, again, very cryptic at the beginning. But, if you wanted to change text on the screen, you had to change it up here, not where the text was originally when it first came out. But then they added in-place editing. And, it was the explosion. I think Windows 95, HMIs, PLCs, right? And then we get ControlLogix with it. And I would also say too, some people may say ControlLogix also owes part of its heritage to the Automax. And I don't know anything about the Reliance Automax and that history there. And I would love to get somebody on the show to talk about that. But would you agree on the HMI side as well? Not only the SCADA side, the InTouches and the iFixes, but on the HM side as well? I mean,
the innovation, and innovation's a big word. It's got a very wide definition, but I believe from the late 60s, early 70s to the mid 90s to the 2000s, there was a huge amount of innovation that happened, maybe not on a yearly basis, but most definitely every 2 years. And I mean, we didn't cover a lot of the other stuff that was possibly involved with regards to OT versus IT, things that were borrowed from the computational side of things. But the innovation in the last 15 to 20 years, Ethernet IP, Modbus TCP, communication stuff, but I just don't see a lot of innovation like we saw if we are talking about 50 years of the PLC, the first 25 years, totally huge innovation. The next 25 years, maybe not so much. What do you think?
I can agree with that because we just did its job, and we didn't realize we did it that well because when they especially became into safety applications and these very critical applications. And I consider none more critical than Space Mountain. You're not going to touch that. Wow, it works, and it proved to work. And I definitely agree. Gentlemen, I sent you some messages on the chat, so take a look at it when you get a chance. But I certainly agree with that. The first 25 years in innovation, and that we did our job too well. That might be a topic for another time.
Everything just works. And trying to upset the apple cart by I'm not quite sure how to voice this, but developers developing for developers, in my opinion and mindset, is not right. Developers need to develop for the process and for the people that are managing it. And again, if you want to use index or indirect addressing, if you want to use structured text, if you want to use sequential function chart, you've either got to be able to invest in the training, and all three of us have done training, so we know how important it is, but we also know that it is a requirement to learn new technologies, because people aren't going to sit down at 8 o'clock at night after dinner and start reading through a manual.
It's
right?
tough. It's tough.
To provide training.
If you got a family, you got obligations in the community.
Oh, absolutely.
It's tough. And I think, and I'm just looking at the time, guys. I think it would be good to pause here. So we're right in the mid, and we didn't even talk about the explosion of Windows-based programming software, RS Logic, WinLogic. We could go on and on about that too, but I think let's pause here. Mid to late 90s. We're talking about the control. We're just getting into the generation of ControlLogix. And I think to just kind of split these up and not go too long any one particular episode, I think this is a good time to stop. And I just want to go around the room with any final thoughts, and we'll start with Gary.
just a fascinating history. And yeah, there was a beginning, and I do agree with your inflection points. I really became aware of the industry maybe mid-early 80s, and but I was right there at the right time. And I put it in a book by Tracy Kidder, which was published in 1981, that is almost biblical proportions to folks like me, geeks, wannabe geeks, because it was the first accessible story of folks like us.
Oh, really? Nice.
So look it up, The Soul of a New Machine by Tracy Kidder. Again, it came out in 81, and a lot of us, and I was new to the industry. Hey, they wrote a story about us. They know who we are, and it was a #1 bestseller. And it was actually The Soul of a New Machine was a story of a reporter, a writer who embedded himself with DEC, and they built this new machine. And just what we all know, what we went through, the processes of getting something out under deadlines, how important. So take a look about that. I'm sure it's still selling copies. Yeah, The Soul of a New Machine, 40 years ago. And amazing. But gentlemen, yeah, I will see you at the next podcast. But I learned so much, and very, 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 very interesting.
All right. Well, don't disconnect. I want to give Jeremy the final word here.
Absolutely.
I honestly, when having grown up in the industry, I started in '77 with Allen-Bradley, and sort of migrated throughout the automation process, even up until my official retirement this July. So 48 years in the industry, and 39 years on my own as a systems integrator and developer and architect, if you will, and as well as being a trainer. I'm just continually fascinated about how far we've come, but really not a lot has changed. The same training issues that you had when 35 years ago, you still have today. The methodology of troubleshooting and using the software, now you're using software instead of a programming terminal, but you still have to have troubleshooting mindset in order to be able to get to the root of the problem. And documentation, of course. It's just about everything has been made easier, but the fundamentals, I believe, are still in place, and those fundamentals need to be understood and learned in order to be successful in the automation business, just generally speaking.
A lot of logic. I always tell people, if you like logic, you'll love this business, because without logic, nothing doesn't work. And then that's a double negative too. Well, I'm going to ask the cast to hang around here. I just want to close out the show. I want to thank everybody who tuned in this week. Again, if you want to join us one weekend and talk about this, we record on Sunday afternoons, please get in contact with me. We'd love to have you. Also, just want to ask you, if you have an extra $10 or $20 in your pocket this month, please consider a donation over at automationmuseum.org. And with that, until next time, my friends, peace.